Okay, so I'm going to record. I'm recording. I actually am recording, but I'm going to finish up on a couple concepts here. And the concepts I'm finishing up are on the copy constructor. And in the examples we just looked at a few minutes ago, when I changed it over and we saw some source code, returned this. So I want to talk about this a little bit. So the return type, if we do an operator, object 1 is equal to object 2, which is equal to object 3, which we actually saw in one of the examples. The return type is the same as the left-hand operator that supports the notation that looks like this. So the function declared as follows, and this is our operators equals that we saw. In the function we included this as the last line, and it was a pointer to itself, which is actually kind of interesting. So it's an important thing to note that we can point to ourselves and return ourselves from a function. So this pointer is what I wanted to talk about. So this pointer is a predefined pointer available to the class member's function. It's actually predefined and given to us, which I know, going back to what Dr. Real was saying, it was, C++ is not a... People don't like C++ for some reason. I don't know why. It's all these inconsistencies. So it's not a likable language for a lot of reasons. This is another reason why. It's another special thing that was put into the language to say we need to figure out how to return something. The problem with C++ is it's one of the first object-oriented versions of C. Objective-C is also an object-oriented version of C, but even Objective-C is better than this. Java was built from scratch. It's not based on a procedural language like C. It's based on its own, and it's purely object-oriented. And we don't have any of these makeshift, things that we put into the language to make it work. C++ has a lot of those things you put into the language to make it work, which makes it a non-friendly language for the most part. But it is still powerful. It is a highly used language, still used with a lot of Microsoft programming. So it just has a lot of workarounds, and this is one of them. So this pointer is a predefined pointer available to the class's member functions, always points to the instance or the object of the class whose function is being called, and is passed as a hidden argument to all non-static member functions. So we're just going to explicitly call it back out when we return it, and can be used to access members that may be hidden by parameters with the same name. So if we have this, we can go this dot something. Here's a case in which we have this number referring to this object, a pointer to this object's number, and it's the integer number here that we're referring to inside of one class. We can also return it. In this particular case, we're returning this, which is a pointer to itself, if you want to think of it that way. So you'll see this with copy constructors because we need to return ourselves. Why do we have to return ourselves? Because we need a return value. We're going to get something out of the equals in terms of the copy that's going to happen with that. So note on the overloaded operators, we can change the meaning of the operator, which is what we're doing. We cannot change the number of operands for the operator. So if it's a plus symbol, it takes 2, the A plus the B on both sides. Only certain operators can be overloaded. Can't overload all operators. Here's a couple that you can't overload. You can't overload the scope resolution operator, which is this one. Or you can't overload the asterisk either, or the dot. Besides of, you can't overload some of the, not all of the operators can be overloaded. Also, on the overloading the type of the operator, the plus plus, the minus minus operators are overloaded differently from the prefix and the postfix notation. So is it one value getting another value? Is it two values being combined? Is it one value turning into another value? All of the different combinations lead itself to different design patterns when we write those methods. And then the overloaded relational operator should always return a Boolean value. Otherwise you're changing the meaning. Meaning if something is less than something else, it should return true or false. So we're always going to return a Boolean for certain things. Overloaded stream operators, as we've seen in a couple of examples I showed you, the cout must reference the input stream or the output stream. So iStream or OStream, which takes on iStream or OStream as parameters, must return a stream as well. Then we have the overloaded operator here, which you might see before. It looks for the array indexes. So you can create classes that behave like arrays, that provide bound checking on subscripts and things. You must consider the constructor, the deconstructor, the overloaded operator. This operator here returns a reference to the object, not the object itself, because it's a reference. This creates a reference because all arrays are references, the reference variables in the language. So it doesn't return this, it returns a reference to this, which is kind of an inconsistency as well. So that was the end of the overloaded operator information that I wanted to give you. I showed you some examples of the object conversion before talking about it. The object conversions are the ability to change one object type into another object type. So we saw the polygons that were rectangles and triangles and how we converted those. So the type of the object that can be converted to another type is what's referred to as object conversion. Automatically done with built-in data types. We can convert one to another. You must write an operator function to perform the conversion. So to convert an feet and inches object to an int, we could do something like this, where it says feet and object, scope resolution operator, int, return feet. So assuming the distance is feet and is the feet inches object allows the statement to say like d is equal to distance, which would make it compatible. Just a side note, no one's ever going to do that. You're just going to change. You're just going to make it of the right. It's like why people don't typecast. You don't want to take a double and a float and an integer and add them all together. Why would you want to do that? Just hold them all as doubles. Hold them all as floats or integers, because then you're going to get conversion issues that go along with that. So, aggregations. An aggregation is a class. So, an aggregation is a class, is a member of the class. It's an aggregate. It belongs to the same grouping. Supports the modeling of the has-a or the is-a relationship. Actually, I'm sorry, it's the has-a, not the is-a. The is-a is a identity thing. A polygon, a triangle is a polygon. A rectangle is a polygon. If you have a has-a, the modeling is a relationship between classes or enclosing or has enclosed inside of it another class or an aggregate. Put it all together. Inside of the time zone class, we might have a date class inside of it, or an employee class might actually have a date to represent the birth date or something, which is an aggregate. It's inside of the other class. So it's nested classes. Same notation for structures within structures as well. It's the same concept. We aggregate them together. Here's a concept here where we have student info and class student that has student info inside of it. That's an aggregation, because we're using this class inside of this class. So some people actually, in other languages, they call them nested classes. You nest a class inside of a class. The scope of the class is only visible inside of that class unless you define it outside of the class. These are defined as two separate classes, so it's an aggregate. A true nested one is the definition of the class is actually inside of the other class. So it doesn't exist outside of that class. Here it does exist. So it's aggregated together. So the aggregate is the grouping, or the whole of all of them combined together. So, okay, so that concludes the chapter 14. And so with the virtual polymorphic and the virtual method functions, I wanted to give you a few more details on that as we conclude sort of the virtual. And then next time we'll start with this concept with some more source code examples and write some virtual methods, abstract classes, because we haven't looked at abstraction and we haven't looked at interface classes yet, which is very similar in terms of its implementation, in terms of other object-oriented implementation. So it's not, if you're familiar with object orientation, it's just the concept extended to C++, sort of like abstraction is. So polymorphism and virtual member functions. So polymorphic by its behaviors, it can change, it can transform. If you have a virtual member function that changes dynamically instead of statically, which means the polygon can change if it's a rectangle, it can change if it's a triangle, or whatever it happens to be, and we can select which one it's going to be by which one it's actually going to reference. So a virtual member function is a function in the base class that expects to be redefined in the virtual class. That's why it's virtual. And so the function is defined with the keyword virtual, as we saw in a source code example already. And so we say virtual void. So it's virtual space the data type, in this case it's void, and then the name of the method, y in this case. Supports dynamic binding. So the function is bound at runtime to a function that is called. And without the virtual method, C++ uses static or compile time binding. So when you put virtual in there, it's dynamically bound instead of being statically bound, which means when the object is created, if we call a polygon, we say, oh, what's your area? But depending upon what it is, it can figure it out. So it can actually print it out. Well, I am a triangle. So because we're late bound, or we're dynamically bound and not statically bound, we can bind our information in terms of what object state we're in. That's polymorphism. It's being the object being able to change dynamically to adapt to whatever it happens to be. Oh, so you're now with this. Okay, so my methods can change in terms of its implementation to whatever it happens to be, especially if it's through a virtual method. So virtual delays the binding. Other than that, we get 5 copies of whatever we had statically and whatever we get, but it doesn't change. It's actually kind of wasteful to statically allocate anything, because it's allocated whether you're going to use it or not. What if you don't use that method? Then you got it. If it's dynamically bound, it just gets wait until you use it. When it gets done, when you create that object, go ahead and allocate it, and it's there for you. So it's actually a little bit faster. It's faster to run dynamically than it is statically, which is kind of funny because C is a statically bound language. C++ is static/dynamic. But it still has too much static left. Java is completely dynamic. Objective-C is completely dynamic. So dynamic languages have a tendency to run faster. So you want your program to run faster, you want to go dynamic on it. Why? Because you delay everything until you need it, and then when you need it, it just allocates what it needs, and it creates what it needs. We don't need 5 different versions of the method. All we need is the one we're going to reference. So consider this function here. It displays a grade, and it's just printing out a get score and a get letter grade. Because the parameter in the display grade function is in the grade display is in the grade activity reference variable. It's referencing any object that is derived from grade activity, which means you can have pass an activity object to a final exam object, or to a pass-fail object, or to any other object actually, and which is also derived from a graded activity, because you can cast the object types back to the same. It's like taking it's like taking a polygon as a concept and a rectangle and a triangle and making them both polygon, and so you can use them all together in terms of its casting. And then let's see, for this particular example, we're going to make a virtual. I believe it's one of these has a virtual method. It's very similar to the polygon example with the area that we went over. So I don't really feel like going through another example, but if we bound whichever method we were running from whichever inherited class that we decided to use, we would bind the method for the grade activity that was associated with that type of activity, of that type of grading. A good example, are you going to give them a letter grade, or are you going to give them a pass-fail grade, or are you going to give them a number, a numeric grade? So you can create all 3 different variations, and they can all come from grade. So then whichever object you decided to treat it as, it would virtually create its own grade activity method that would return the grade in whatever format the grade was supposed to be in for that particular activity. Let's see. So virtual function is dynamically bound and calls at runtime. So C++ determines what type of object is making the call and binds the function to the appropriate version of that function. So if it's a rectangle, then it's going to make the rectangle area. So if it's a triangle, it's going to make the triangle area. And we saw this before, but the virtual keyword is put in front of it. So to make it place, that's all you have to do actually. All you have to do is place the keyword virtual in front of it, in front of the return type in the base class declaration. Compiler will not bind the function to calls. Instead, the program will bind them at runtime instead. It just delays the binding till runtime. Virtual is pretty interesting that way. I'm not going to go through this example because we've already done one that's very similar to it. It's kind of tedious to do it again. So polymorphism requires references or pointers in order for it to actually be implemented in C++. Polymorphic behavior is only possible when the object is referenced by a reference variable or a pointer, which is why pointers are kind of the de facto standard for this. So as demonstrated in the pointer of the polygon, forget this example, the polygon, the rectangle, and the triangle is a better example for that. So base class pointers can define a pointer of a base class object and can assign it to a reference of the derived class object, which is what we did before. So we took polygon 1 and had it equal to a new rectangle, polygon 2 and had it equal to a new triangle. That's the base class. Don't worry about this example. That's the base class that we made equal to a derived class that was for it. That gives us the polymorphism. We have two bases. So in a lot of cases, you'll see a lot of derived classes from bases, and then they'll all be of the base type, because all the objects at that point can be used all together. So it gives us more polymorphic behavior. It really enforces polymorphism as a feature of object orientation. Why do we want that? Because we want flexibility. We're going to make one function, it's going to take a polygon. And if it takes a polygon as an object type, send it any polygon. You can have millions of polygons, just send it a polygon. We don't have to make 5 different functions, one that takes a triangle, one that takes a rectangle, one that takes whatever we create from that. So there's not that many polygons, but long story short, it gives us polymorphic behavior because they're all polygons. We treat them all the same. It's kind of like students. We take all the student objects in the program. They all have different levels. They've all taken different classes. They're all different majors, but they're all students. So we can have individual inherited students that have different qualities, and we can treat all the students the same and put them all in the database the same, and they all work the same, and the function calls work with them as references to students. But one student is a graduate student, and the other student is a doctorate student, or one student is a this or that. So kind of the same concept. So that's another example of polymorphism. You want to know what polymorphic behavior is, because what you're going to get on the final exam is the API. Examples of abstraction, example of polymorphism, inheritance, and encapsulation in terms of their meanings and how they're implemented in the C++ language, because this class is actually titled Object-Oriented Programming in C++. So we're focusing on the object-oriented nature of the language. So that's really a lot of the focus of the questions. So some of those people who are preparing within the next couple months to take the final or thinking about it, you know, remember all the object-oriented things. It's highly object-oriented in its focus. So there's your example of another form of polymorphism. So operator overloading is polymorphic as well. It allows you to add 2 points together instead of 2 integers or 2 floats. And the operator works the same way, which is the concept of overloading. You overload operators, you overload methods, you overload constructors, you overload everything so that you can adapt it, and that's a form of polymorphism. Same thing as the virtual concept of abstraction, making abstract methods that you're overloading. You're really overloading, but you're not really overloading, you're implementing. You're delaying the implementation, so you're creating polymorphic objects in that particular case, because the object is morphing to work with whatever environment it needs to work with, given what type of object it is, and then you can cast the objects back and forth to make them all compatible. So base class pointers are references. Only know about the members of the base class. So you don't use a base class pointer to call the derived class function. You only use it for the base class. But if it is a derived class, you can reference it as a derived class. And if you're referencing it as the derived class, then you're going to get all the derived class virtual method implementations. So redefining the function in the derived class will be ignored unless the base class declares the function virtual. So you create the reference as the base polygon. You create a rectangle from that. It only knows about the polygon stuff. If you don't make it virtual and you implement it and then you cast it from a base to something up higher, not going to know about it. Polygons aren't going to know about anything related to areas, and that's what we noticed before the virtual was implemented. So we use virtual a lot just to make the base aware of the derived class, make them aware of what could be possibilities could be in terms of the overloading. So redefining versus overloading. So in C++, you redefine functions that are statically bound and overridden functions that are dynamically bound. So you override dynamic stuff, you redefine static stuff. Is it really there? Yeah, but you got to cast the object. So as an example, you can have a person and you can have an employee, and we had that something method. We overrode it. It wasn't abstract, it wasn't dynamically, it was statically bound. So if you treat the thing as a person, we're supposed to get a person method. We treat it like an employee, we get the employee method, but it's the same method. So it's overridden and redefined given the class level. So at a particular level, all you're going to see is certain things. So it's actually hiding. It's still there, but it's hidden. You can do that with variables as well. You can have integer I in a base class and then derive a couple of classes from that and have integer I in those classes too. And you have multiple different of integer i's, and depends upon how you cast the object as to which integer I you're going to run into. That's confusing. But you've redefined it instead of overloading it. So it's a different concept. You can redefine and you can overload, two separate concepts. So a virtual function is overridden and a non-virtual function is redefined. You added it to it, you redefined it, but you didn't overload it technically. So that's why virtual is kind of an important concept to take away, because that's where you're creating that polymorphic behavior, because that's when you're really overriding. You're not really overriding, you're complementing, you're adding something to it when you redefine it. So virtual destructors. So it's a good idea to make a destructor virtual if the class could ever become a base class, because otherwise it's not going to run. So remember what happened with the area? Polygon didn't know about area. Well, if the class could become a polygon, and you've got dynamically allocated memory, and you're going to have a destructor, make the destructor virtual. That way it will actually go up through the lines and remove all the memory. It knows about it, which is kind of funny. So kind of, well, what can you not make virtual? Practically nothing. So you can make anything virtual. So you can make a destructor virtual. That way the base, if you're ever going to reference it as a base class and then you're going to destroy the base class, well then you're going to leave memory behind in the derived classes if you actually had a destructor, because you're not going to run those destructors because you're not going to know about it. So otherwise the compiler will perform static binding on a destructor if the class ever is a derived form, so ever derived from it. So there's an example that goes along with it, but I don't know if you necessarily need to see that example. You just have to know how destructors work, and knowing that if the base class doesn't know about the destructor, it can't run it. If it's not going to run it, you're not going to have a destructor that works. So abstract base classes and pure virtual functions are our last topic for this weekend, actually. So there's a difference. An abstract base class is one that has a virtual method in it. So it has an abstract method. So pure virtual function is a virtual function that must be overridden in the derived class that has objects. If you don't override it, the compiler is going to complain. An abstract class contains at least one pure virtual function. So if you've got an abstract and virtual are practically the same words. Why did they use virtual? Don't ask me. Other languages called it abstract. We don't have the word abstract in the language. There's no such thing as the word abstract in this language, but the concept exists. So we have a virtual function. If we have a virtual function, virtual method inside of a class, the class is abstract by definition. So, and if we have a pure virtual one in there, then we actually created the abstract. Without the pure, we don't technically have an abstract class because we have to define that one. But we have similar qualities between the two of them. So pure virtual is one must be overridden. Abstract classes technically have one pure virtual function in it. What makes it pure is this equals 0. So we put equals 0 on the end of the method, and now it's pure. We leave the equals 0 off, it's not pure, which means we could delay it. We don't necessarily have to implement it if we don't want to implement it. So does it really make it an abstract class if we don't have to implement it? Technically, no. Can you make an instance of it? No. It has a virtual method in there, compiler's going to complain. So you can't make an instance of either one, but it's not technically abstract unless it's pure, because there's no requirement that you actually have to implement anything unless you have a pure method in there, which, you know, abstract classes by definition cannot have to be implemented because it's abstract. The requirement makes it so you have to implement it. That's why you put the pure in here, and then, oh, now you have to implement it. So the equals 0 indicates a pure virtual function must have no function definition in the base class. You're not allowed to define it. So what a lot of people do is they don't make it pure. Define some basic functionality, you know, and width times the height. And then what ends up happening is that you don't implement it. Oh, let's just wait with that one. Let's not implement it. And then you get this weird behavior that comes back. And when you call the area, it says, oh, it's a circle, but I got width times the height. I'm like, oh, what's the area of that? You come out with the wrong answer, essentially, which is going to actually create some confusion. So people just go virtual. I mean, just go pure. So abstract base classes and pure virtual functions. By definition, the abstract base class is the class that can have no objects, is what I was saying before. You cannot make an object of an abstract base class. Serves as a basis for derived classes and may or will have objects. So you make objects of derived classes from the base class. So you can't make an instance of that particular object, but you can reference it, as we saw with the polygon, which was a, well, actually it was a pure virtual. It said equals 0 on it. It turned into a reference, but we didn't make an we didn't do a new polygon. If we do a new polygon, we're going to have an error message that comes out of that. It's going to say, sorry, it's abstract. Can't make an instance of an abstract class. So the class becomes an abstract class with one or more of its members' functions being a pure virtual function. So multiple inheritance. This is real easy. We just string them with a comma. So a derived class can have more than one base class. So remember, public employee colon, you know, it says class employee colon public person, comma, dog, comma, whatever we want. We just separate them out. Here it is here. Class cube colon public square, comma, oh yeah, I left out the public. Public rectangle solid, comma, public something else, comma, public something else again, comma. When you're all done, put a semicolon at the end of it. Or actually, yeah, continue with the class definition at the end of it. You just separate them by commas. So you can't do this in Java. In Java, you can extend only one class, and you implement interfaces. So you extend base class, a derived class extends base class, implements interface A, comma, B, comma, C, comma, D. No such thing as an interface in C++. No interface classes. We just have classes. So class A, we don't have the keyword extends, we have colon. Call it extends for lack of better words. Extends class A, comma, class B, comma, class C. It's multiple class inheritance, multiple line inheritance. What does that do? Gives you some pretty messed up objects. It gives you the ability to multiply inherit from things that don't make sense. In Java, you can't do that. In Java, you got single line inheritance, but you got multiple with interfaces. So here you use these as interfaces, and you make abstract classes, and you extend abstract classes, which are really interfaces. So they're all mixed together. There's no clear separation. Instead, they use the word interface and they call it the .h file, the public interface. Like, well, that's not the same. Not the same. If you're familiar with Java, you know what an interface is. Isn't it kind of like an abstract class? It is. Interfaces could be abstract classes, but the problem is you can't inherit more than one abstract class. So you got one abstract class you're inheriting from, and you create a bunch of interfaces, and you implement all those interfaces. Well, chicken before the egg, come back to the C++, why even bother with that? Just multiple class inheritance. They're all classes, no interfaces. They all do. But the programmer's got to remember that you can't implement, you could implement from many different classes if you want to. But what is a dog and a person and a cat going into an employee for? doesn't make any sense, which is why I kind of started out with the dog. I threw the dog in there because I'm going to take that example and we'll do multiple interface next time. So the next weekend we meet, we're going to implement abstract classes and this, I'm doing this quote-unquote interface concept along with multiple inheritance. So we'll take a dog and a cat and a person and we'll put them into a student or an employee or something. We'll see that it works, but it may not necessarily make any logical sense. And we can also make them all abstract by putting virtual methods in each one of them. So what would that do? It would make sense if we had, let's say for example, employee, and it came from person, comma, print, or enrollment, or register. So employee got registration methods, or it got print methods, to print methods. So all of the employees were able to print. And then you can take that class and put it in every other one. Students and staff, they all get print or printable or something. So you make generic behavior, you stick it inside of classes and you inherit those classes so you can reuse the behavior without having to re-implement it in every single one of the new classes. So you can inherit the full-on implementation, and it takes a generic object reference. So you send an employee object to the overloaded print method or something, and the method over here is going to print out employee information, and then it prints out staff information, prints out student information. So it's a way of combining efforts to facilitate reuse, create a hierarchy of reusable components, of generic object types, and create some consistency among all your objects, which is kind of like what an interface does. But you're not technically using an interface concept, you're multiple inheriting. So derived class can have more than one base class. So each base class can have its own access to specific derived class definitions. So a square could have a class rectangle solid and class square that goes into class cube that comes out of that. Color components, print components, things that would be generic among many different types of objects. Printing is one of them, actually. That's kind of generic among a lot of different types of objects, the same object kind of class or hierarchy. So we just separate them by commas and the concept is the same. We just get everything. So if we have an employee and we inherit a person in there, we get all the person, well, we get comma, we get all the dog, comma, all the cat, comma, everything else we stick in there. Doesn't make any sense, probably not in that particular example, but it might if we planned it out correctly. So multiple inheritance, in this case, the arguments can be passed to both the base class constructors. So remember the overloading of the constructors where in employee we passed information back to person, pass it back to anyone. So the employee, not to go off on a weird tangent here, that's inheriting from person and cat and dog, could have a constructor that says, okay, the person's got 2 legs and a tail and fur, and it could have all the characteristics, and we could make a dog inside of the employee and a cat inside of the employee and a person inside of the employee and pass all the information back. So it's like new employee Barb, and in there we got the name, the height, the weight, the tail, the number of teeth, the hair quality, the kind of hair, is it fur or is it hair? I don't know, the color of the something or other, whatever was specific to all these things, and then pass it back. So the constructor for the employee just sets the employee's characteristics, and all the stuff for the dog goes to the dog, the cat goes to the cat. And now we have some pretty interesting hybrid animals going on here. That case, I don't know about all that stuff, but it's possible with C++. So arguments can be passed to the base class constructor by saying, in this particular case, cube, inside colon, a square. We separate them all by commas. So this is the constructor for the cube. The cube constructor takes in the side, and then we send square to the side, and we're going to send rectangle solid to side, comma side, looks like 3 sides going there. We send it all back, so when we make the previous constructors of the previous base classes that are all inside of this derived class can all get initialized correctly by the information that we take in. So base class constructors are called in the order given by the class declaration. So remember, when we make an employee, we get a person first, then we get the employee second. So it depends on what order we string them. when we say inherit from person, comma, dog, comma, cat, we're going to get cat, dog, person, employee. It goes backwards. So the last one that we inherit from is the first one we create. It goes all the way up the line backwards. So it's the order that we put them in, not the order used in the constructor. So this constructor order here will vary, because now we have an order. So whenever we put them here, it doesn't matter. It's how we strung them in when we wrote the definition of the class that's going to matter. So problem with the concept, what if the base classes have member variables or functions with the same name? Because you're going to put multiple ones in now. They all have names to them. Oh man. Person's got a name, dog's got a name, cat's got a name. Solution drive class redefines multiply defined functions. So if you all have name, get name, set name, and you put it in employee, that's going to override all of them. So the derived class will redefine all of the base class matching names. So it takes care of the problem. Derived class invoke member functions a particular base class using a scope resolution operator as well. So you can get back, cat, scope resolution, get name, and you can basically call back through all the different derived classes. This is a problem you get mostly with the redefinition, actually, and trying to figure out, well, which one am I redefining, and which one do I want to use? And compiler errors will occur if derived class use the base class function without one of these solutions. The solutions are to redefine it with multiple defined functions, or to use the scope resolution operator to say, I'm redefining this one, I'm redefining that one. So fortunately for you, we're not going to use multiple inheritance in any of the source code examples or any of the things. But know that C++ supports multiple inheritance. It's not a single line inheritance, and there's no such thing as the interface. Instead, we have the abstract class. We can't actually make an abstract class. It's a concept. So hopefully with this multiple inheritance, some of these classes are abstract. And they're acting sort of like interfaces. So, but the syntax is slightly different. So, all right. So that concludes this weekend, believe it or not. And next time we come, it's going to be 2 months from now. It's going to be July something, July 22nd or something like that. Excuse me, August. See, yesterday I thought it was July. Now I'm back in June. So next time we come, it's going to be August something. Let's take a look at the calendar here, actually. It's going to be August. Do I still have internet access? I do. That's good. Next time we come, it's going to be August 24th, August 25th weekend. Is that right? Yeah. Which means it's after all of the assignments are due on the 22nd. So just like attendance, if you missed the 22nd, you missed it. Don't come here with all your assignments. Here, I'm going to give them to you in class. No, they have to be, I had this happen to me actually. They have to be uploaded into the EMS. I can't take it in class, print it out in class on the 24th. It's not going to happen that way. It has to be uploaded by the 22nd into the EMS. It can't be emailed to me either, but if you're writing assignments and you think, I want to send you this assignment, I want to see if it looks good, you can email me assignments. Some of you are doing it, which is great, and I can look at it and I can say, hey, this looks good, upload it, I'm not going to grade it for you, but I'll tell you whether or not it's going to earn you full credit or not. But I can't issue you a grade for it. The grade will be issued through the EMS system once you've uploaded it into the system and formally submitted it that way. So between now and then you want to do the midterm as well. The midterm is not due until the 22nd, but it's 25%, as long as the CSLO 25%, 25% on the assignments, 25% on the final exam. Final exam is going to be Sunday at 3 o'clock. In the afternoon. I can't change that date either. So make sure when you book your flight, it's past, it's going to take about an hour, maybe hour and a half, 2 hours. Maybe on the safe side, go 2 hours, just in case. So 3, 4, 5. Don't leave until 5:36-ish if you're coming out of San Jose. Because I don't know what type of flight schedules are going to be, but plan it's going to start at 3 o'clock. I can't give it to you any earlier. It's going to go for about, if you're good, it's multiple choice. It's going to take you about an hour. Maybe. I can't guarantee it, though. A lot, 2 hours, and you'll be good. We'll be out by 5 o'clock, probably. Questions, comments, concerns? Well, thanks for showing up. Thanks for staying till the end. We had a strong finish. It's good.